All right, let's do a quick follow-up on the last one. It has been a while, sorry, I was busy, and yeah, I just wasn't in the mood for it. So let's continue. So we were sending MQTT messages over from our ESP32, and that kind of worked. Uh, since then, I discovered a few things. First of all, I used I don't have it here, the MQTT UI, and somehow that sometimes doesn't seem to work for me. So now I'm using the text UI, which is pretty nice. So it's MQTT 2E, I think. Yeah, works for me. So let's continue. Where were we? We had uh, three things. We had the main that set up stuff, that it runs the connect, so that's keeping the Wi-Fi connected. Then the run network that actually just runs the network, and send an MQTT message, which does the interesting stuff. That's one single loop up here. Checks if the link is up. DNS resolves a host. Connects to a TCP port, creates an MQTT client, connects to the broker and sends a message, waits for 5 seconds and does it all over again. So, a bunch of things that I would like to improve. First of all, in terms of structure. Right now we are only, of course, printing a simple hello there text message, but generally you want to, that data comes from somewhere. You want to somehow, uh, yeah, send something useful. And right now you could do it from here, but that would kind of smoosh your whole architecture together. Because, for example, the most common cases I see is for microcontrollers like this is some sensor, like you would measure temperature or something like that, and you send that over MQTT, and somewhere else you listen to that feed, and that's fine. But right here, that would imply that in the middle of this loop, you need to connect to your sensor somehow, read the sensor, and then and then send it, and then you get this one big loop, and that's kind of like programming C, and then the whole thing of using Rust and the whole uh, my whole mission to create a bit more uh, software engineering principles to embedded programming kind of falls apart. So let's have a little bit of an attempt there to make that better. Also, second thing I would like to improve is now I'm disconnecting and reconnecting to the server all the time. And I don't think the server really likes that. Sometimes it gets unreliable, and then after a while it recovers. But I think somehow it doesn't like one connection constantly connecting and disconnecting. I might be seeing ghosts, I don't know. But it's definitely not efficient, right? If you have you're constantly sending messages, there is no need to always disconnect the socket. However, if there is a problem with the socket, you do need to somehow rediscover it. So, let's have a look. Let's start with my software engineering argument. So, let's imagine that let's go to the main. We have those three tasks, and we want to create a fourth one that actually reads the temperature of the sensor or whatnot. So let's create a quick task. Now, of course, I'm not gonna read the sensor right now. So data. So probably you would pass in some GPIO pins or I2C, I don't know. But right now, let's just keep it as a kind of pseudocode in a sense. So I just create some code, and let's imagine there's a loop in here. Read sensor, send to MQTT. So that would be the loop, and then delay a bit. Something like that. That's what we would do. The next question would be, how do we get that message to that task? Because we don't, again, I'm repeating myself, I know, but these things, they look like methods, but they're not really methods. They're tasks. They will be started once and they keep running basically forever. So you should look at them as like services, microservices in a sense. So the parameters are just like startup stuff. You won't call them later. So what we need for that is some channels. Channels are perfect for this kind of stuff. Now, for channels, we need, first of all, let me go to the, so this one is still happily sending data to the hello there. I actually found some of you sending data. I don't know who, but I monitored the topic. I saw some data and I thought, oh, I forgot to unplug my ESP32, but it wasn't plugged in. So it was someone else using my code, and that's amazing. I'm so glad. Nice if somebody plays around with it. Anyway, adding channels. So right now I need a way to send data from this task to this task. Alright, we're gonna use cargo add embassy sync. So there's synchronization primitives. There are channels, there are pub sub channels, there are other things I can't think of right now, but the channel is what we need here. So what does that look like? Let's create a channel, and we call it outbox channel. So it's stuff we want to send, and I'll explain a bit why exactly I call it like that. Channel, embassy sync channel, indeed, new, and I need to specify the type with a mutex, a type, and a number. Let's go channel mutex, no raw mutex is fine. What's wrong? Yeah, the first is weird. Let's call it a string, and let's call it 5. Let's see if these are there. Indeed. Yeah. Let's create a type alias, because generally in this case the string is fine. That's not really the problem, but it's more like yeah, let's create a type alias because it's kind of easier on expanding the code. So we call it message, and I actually don't want to just do a string. I would like a string for the topic and then a byte array. Fac u8. Which string do we take? We have allocator, so that's fine, and we can use vector as well. So now we can just use this instead of the type here. So this message is a tuple of a string and a payload. And the advantage of doing this is that you end up, yeah, you can change it easily, and you can also embed the topic inside the message. So if you want to send to multiple topics, you just can, you don't need to mess with anything. Okay, this is an outbox channel. We could pass it into both methods, but we need it to be static because these tasks, as I said before, typically live forever or forever-ish. And then the borrow checker needs to be sure that whatever I pass into it also lives forever. So we can box leak that. What I usually do, I just reuse the same variable name, and I do box leak box new. I do with the outbox channel. It feels a little bit clunky, I have to say. So if I show the types, you see now it's a mutable borrow of that channel, and I pass the first one in. And I prefer that to pasting everything together, because then you need to somehow you need to supply then the type here, and then it gets messy, and yeah, this is clear to me. In any case, we have the outbox channel. Let's add it to the sensor data. But actually we don't need to add the whole channel, because that would give our age-old problem with ownership. Because who owns the channel? The sender or the receiver? Neither, right, in a sense. So first let's add the method here. So to start the service, read sensor data and unwrap it. So now we started, nothing happens. It will actually death loop, so this won't work at all because there is no, just before, otherwise I might forget. So after seconds, doesn't matter, but you need something, because otherwise it gets in such a tight loop that it will never relinquish control and your controller will just hang. And I don't want to be staring blankly at the screen while that is. So let's make it easy. So, but again, back to the ownership. So we have this channel. We want to give the sensor data the possibility to send data over the channel. But we can't really put a channel in there, because then nobody else can use it, and then beside the point. But what we can do is we can create a sender. So that's a sort of a sender perspective on the data, and you can only send, and you can make multiple. And the same side, you also have receiver, and you can make multiple of those as well. So what would that look like? So we need to add a parameter here, sender. It is a sender, and I need to add the same generic parameters, also the static, of course, because tasks, no raw mutex, and the message, and let's call it 5 again. Now I would usually advocate to create types for these as well, because now that 5 is kind of random, and yeah, you would want to put that in one spot instead of sprinkling it all over your code. So I think in the RC car I actually did a bit better job of that. So I have a sender here, and now I could do sender.send, and then I send a message. So that would be like some topic and some data as bytes. To fact then, I suppose. And this needs to be to owned. I need to await it, of course. So this is pretty ugly, but I sent a tuple with a topic and some bytes, and then I await it. Right, so that's quite straightforward, and then I wait a little bit and I keep on looping. What is next? So now I send it into the channel. This will work for a few times. Well, exactly 5 times, because then the channel is full and nobody is reading it. So I need to add the channel as well to the sending side of the MQTT side, because I need to give it a receiver. So I add here outbox channel dot receiver. Now just copy paste this quickly and change it into receiver on the MQTT side. So we had the stack. After that we are going to add this one. It's not a sender, it's a receiver. It's a receiver. Yeah, that one. Do the imports. Is this public enough? I suppose. So now I have a receiver. So this loop, it's the outer loop. We do some stuff, and up to here we have an MQTT client, and from that point on we connect. So from here we have a functional MQTT client. It's actually ready to send some messages. So what would that look like? Let's do a loop here and not continually disconnect, and we move all this in here. So now at least we don't reconnect every single time. Let's, instead of always sending a message, we're gonna go to the receiver and we're gonna receive and await that. So we query a message, and this will wait in its non-blocking way until there's a message, and then it will continue. So this will not loop simply because there is a timer. I can remove this one, it will be fine. So I also don't need the counter, and I can deconstruct it even into because it's a tuple, right? If I show this, you see it's a string and vector. So let's deconstruct it into a topic and a payload, and then we use this topic here, and we use as ref or reference, and this one we don't need the format anymore, we don't need the s bytes, we just say payload, and the quality of service is fine for now. So let's keep the log so we know something happened. Alrighty. Should that be okay? Let's not send it to topic. So let's continue using this one, ESP32 test topic. Let's see what that does. Cargo run. Let's flash it nice and quick. So this seems to connect, and here we see ABC being sent. That was smooth. So what have we gained? Here this code can send messages through a channel. It doesn't need to know anything about MQTT, only that you need to send a topic and a payload, which is nice. And yeah, and in the MQTT, it's a generic MQTT sending function. You could paste it into another project which sends something completely different. It's fine. We should make a type alias for this. I mean, ideally you would make it into a generic, but you can't use that for tasks in Embassy. So that works. How are we doing for time? So now we are receiving. What else can we do to make this nicer? One thing, what would be nice, is that we could also, for example, this sends every 5 seconds, and that's hard-coded right now. But let's think about how could we configure it also using MQTT. So now it's sending data on a regular interval every 5 seconds, but if we want to send data back to it also over a topic, then we don't need to hard code it anymore. So let's create another channel for incoming data. So we create, copy paste the whole thing, and we call it an inbox channel. So, what's it complaining about? Yeah, the dangers of copy pasting. You forget one. Okay, thank you, type checker. So an inbox, what would that look like? So we end up, this one would create an inbox, a receiver that receives configuration data. So to make that clear, config receiver, something like receiver, and that would be a receiver. I will use the same type. Do I need to? What do I need? I will use the same type for now. So it doesn't have to be, of course. It can be different type. But let's do that for now. And it needs a lifetime as well. So I call it static. And then this part is happy. This part is not. So it's a inbox channel receiver. Okay, so now we have the inbox as well. So what would that look like? So we are looping, and we're gonna listen if something appeared on that inbox. But we don't know, right? Maybe there is no configuration data. Maybe everything is fine. So first, let's create a variable, a mutable variable. Call it delay, and it's 5. I think it should be a U64. That's just a variable, and we use that one to steer our delay. So if we make the delay smaller, we're going to send quicker. If it's bigger, obviously send slower. But we can control that from the outside. So how do we do that? On the configuration receiver, we can call try receive. We can call receive, but then that means that this will block this loop until something there is something to receive. That's not what we want. We wanted this thing to just loop at whatever speed it wants to loop, and if there's something, it wants to update that. But we don't want to do an actual receive here, because if there is nothing, it's fine, but then continue. So we do try receive. Oh, what was it? Try receive, indeed. and we need to match that because we need to check on all the possibilities. So it says okay if there is something, and if there is nothing, it says error, which is barely an error in this case. We're just gonna ignore that because then we're gonna continue our business as usual. So what are we gonna get? So we get a message, right? Well, we are gonna get a tuple, topic, and a message. I'm actually not that interested in the topic to begin with, so I'll call it underscore. I assume that this is the topic I'm subscribed to. So here we have a message with it, which is a string, I think. Oh no, bytes, of course. So we need to parse that. How do we parse that? We first need to create UTF-8 from it. So we do from UTF-8 and we put in the message. Message not the right word, let's call it payload. Like this, I think. We unwrap it. So now we have a string. And then we need to create a U64 from it. So what do we think? What was that? That was something in U64, I think. Yeah, from string radix. So you put in the string and radix 10. And what does this do? This parses a number. So I'm unwrapping it. That's not a great thing to do. But we'll deal with that another time. So I update delay to this new value. Now this is a little data. Let's do unwrap or. So if it's not correct, we put it back to 5 because we definitely don't want it to be 0, because then this whole thing will get into a tight loop and nothing will work anymore. Okay, but we have some more stuff to do because this is on the we didn't really deal with it on the other side, so nothing will ever get into this inbox channel because we need to give it a sender to the MQTT code. So let's do that. Right here we take the inbox channel and we take a sender. I'll just copy this thing because it's all the same type, and we add it here. So that's imported. This one, and we call it configuration. Nah, the sender is okay. We want it to be generic MQTT stuff. Okay, so where does that leave us? First of all, we have an interesting situation here. So we're in this loop, and two things can happen, right? So this can happen, the receive from the MQTT, or something from the so either we get something from the channel we are using to send data, so sent by the sensor, or someone posts a new configuration on the MQTT bus we somehow subscribe to, and we want to send that back. So there are two possibilities. right? Two things that might happen. And for that we need to use a primitive that's called select. And I need to add that. And I think that's in cargo add embassy futures, I suppose. Let's see. Excellent. So select, there's also some other variants, select 2, 3 or 4. Select, the general select is just select with 2. And there you can define two things that might happen. And then if one of those two happen, then you get a notification of that and you can await the whole thing, right? So one side will be the receive, right? Receive. And the other will be the MQTT client dot receive message, right? So, and then we await the whole thing. Is that correct? What's the problem? I need to match it, of course. Missing match arm, so we fill that. And then we add the extra brace for some reason. So, what are we doing now? So the reason is we can't just do an await from one of those, is then it will wait for one. And as long as, until that happens, it won't continue. Now it will continue if this happens or if that happens. And it will say in an enum, first or second. In the case of first, it's the receive. The second one is the receive from the MQTT side. Yeah, so let's clean this up a little bit. Can we replace it somehow? I thought you could. Let's do it like this then. So we have two things, and these types could be very different. Right now they are the same, but doesn't really need to be. So first, when we receive something in the channel, basically the what we did before still holds. So we're gonna deconstruct that here, and then we're gonna send a message using those. So basically this. In the second case, what are we gonna do? So again, we're gonna deconstruct, right? So that's gonna be pretty much the same. I think I'm not entirely sure. Let's see. What's that supposed to be? It's a result from the... So, yeah. It's a bit of a dilemma. I mean, right now I could get away, I think, with just unwrapping the thing. No, I can't. Oh well, let's deal with it. So we have this thing. A little bit in doubt how to deal with this. Oh well. Let's call it result. Not a great name. Match result. Fill the match. And in the case of an error, I think it would be best to just break. And then it will break this loop. And if it's okay, then it is the same deconstruction again. Let's see what types they are. String slice and byte array. Okay, so we need to clone those, but that's okay. And then we're going to send that into this thing. Alrighty. So sender, send a message. So that's topic dot to owned and payload to vec and await. Is that correct? Okay. I think that looks decent. And this one we should just remove. I don't remember how to, because I would actually like to break to this loop. No, this is okay, I think. Let's see. Let's run it. I have no idea actually how to send messages with this one, because this was just running, of course. Let's see how it's doing. Still need to flash it. I will try it with the MQTT X thingy. It didn't seem to show new messages for me somehow, so I switched to the TUI, but I'll try it again for sending. Did I log anything? Let me check. This one doesn't say a thing, and neither does this one. So we made it really quiet. Is it running again? I don't think so. Oh, it is. How does that work? Okay. This is getting there. We should have changed the... Yeah, of course it was still running all that time. But is it still running? 52, 24. I don't think it is. Let us see. Let's add some logging. So info sending from sensor, something like that. And oops, in the MQTT, forgot to import, I suppose. Yeah. And from the MQTT, I will say, well, at least loop. Then at least we see if something moves or not. And that's a macro. Okay. I did forget to subscribe to the whatever the configuration topic is. So that's definitely not gonna do anything. So it seems to be sending from the sensor, but it doesn't seem to arrive on the other side. So I probably think after 5 it will block because the... Oh, that's interesting. Now it works. Did you see that? Well, here it is. Like it sent a few times and somehow it didn't work. And now it seems to be caught up. So now there should be data here again. That's weird. I'm gonna blame the MQTT broker for that, because we didn't really change anything beside of the log messages. So that works, but I forgot to subscribe to anything, because this receive message is never ever going to happen if you don't subscribe to anything, right? So let's do that. Client, subscribe to topic, ESP32, test configuration. Oh wait, so all right, and unwrap. So with this, we should get a message which should only contain UTF-8 text of a number, and that's the number of seconds it will wait until it will send again. All right, let's see if that happens. Oh, that's the wrong one. Let's get back ESP32 test topic underscores test topic. This thing is wild. There's so much stuff happening. All right, let's run this one again. And what just happened before that it blocked for a while is also an interesting thing to think about, right? If it would reach a certain number of messages, should it block then until it can send those messages, or should it just discard the old one? For most measurements, I guess it makes more sense to discard the old ones, but that will depend on the situation, I suppose. Somehow the Wi-Fi seemed to struggle a little bit. That is weird. So I think that somehow that subscription call is hanging. Did not see that one coming. Let's see. ESP subscribe. Yeah, it never said loop at all, right? So that's another thing to take into consideration, because I think that there might be a chance that it will resolve itself after a while, but it will never notice. So this is, I guess, a sort of deadlock situation. I'm also not sure if maybe you're obliged to add a client ID. Don't think I did that. That's weird, right? Or is it maybe waiting until that topic actually exists? Would that be it? Let me send a message to that topic. Oh, sorry about the brightness. I don't think this has a dark mode. What was the topic? Test configuration. That was here. So let's send this. Disconnected. Yes. So that's live and learn, right? So if you do subscribe to a topic and a topic doesn't exist, it waits until it exists. Didn't know that. So now it's happy again, and let's see if we can make it quicker by saying 1 and see if it receives that. I don't think it did. Did I get that right? Test configuration, ESP32 test configuration. Let's put a log line here. Configuration found with a topic, I suppose. Let's see if we catch it receiving configuration. I wanted to actually clean up the code a little bit, do some bit nicer error handling, because I've been slacking on that a little bit. But I'm gonna call it a night if we get this to work. So this thing is just looping, but it doesn't seem to have connected to the MQTT server just yet. I don't see any looping going on. Is this doing something? It's weird that it's flaky. I mean, I get it, it's a free service, but it's we didn't change anything at this point. I can try, maybe it's forgotten that I need to send something again to wake it. No, not really. Let's restart it. I don't like these things. Um, yeah, we didn't change anything since the last time, so it should be fine. Maybe it likes it when we give it a no, add, I think. How do you? Or maybe it was the config. My theory is that somehow, add client ID, that if you can't be distinguished from others, it might not like it. I don't know. I need to make it mutable. And now it's working in the meantime. Okay, well, never mind that then for now. Let's see if what happens if we send something here. So we say 1. Did it notice? I don't think so. ESP32 test configuration. Is that correct? Yeah, it is. Should the quality of service match? It does match. That is odd. This one is looping. That seems to be fine. I don't trust this client at all. Let's see if we can send something from this thing. What was it called? Configuration test, right? Test configuration. Configuration. No. I don't think it does anything. So let's see what this thing can do. Can we send messages with this? Add username broker with the topic and publish. Okay, so we do the broker, you say topic ESP32, no, test configuration. And then command publish. And dash, okay. That's annoying. If I just press P, does that do anything? I can search. Oh, that was me. Maybe I just do publish. MQTT publish topic payload. Okay, so I just say this. This is still running, yeah. It read the configuration. And now it moves every second. You see it's quicker now. If I say 10, it's really slow. Yeah. And if I do 0, it will probably explode. I'm not gonna do that. Needs to pick it up and then it's quick again. So what did we do? We separated the code for whatever data we are sending away from the MQTT code. We made it configurable remotely. So if we are, I don't know, measuring the humidity of a plant or something like that, we can configure that. We can configure other stuff. We can put whatever we want in this message. Now we have in both directions for the data and for the configuration the same type, which of course doesn't need to be. And on the MQTT side, we were just looping, but now we're looping a bit tighter so we don't reconnect every single time. We use a select to listen to two things at the same time, either something from our internal channel from the sensor to send it, or something coming in from the MQTT side from the subscription, and then we send it to the reverse channel in a sense. And those do their thing, and if there's a configuration, we update the configuration, and we can make that as fancy as we want. Right now it was just a single number in UTF-8, which is about the crudest protocol you can think of, but you can maybe use postguard like I did in the remote control car. Then you just create your static type and you can put any configuration data you want, or JSON or whatever. Yeah, I wanted to do a bit more error handling because right now it is a little bit right here, a little bit sketchy. Like if this would error out, everything doesn't unwrap now. So basically, if something fails, it will restart the device. Not the worst, but it's a bit sloppy, I think. So I need to work on that. But yeah, it's going on for an hour exactly now. So I'll call it here. Thank you for hanging out with me and writing some embedded code. And next time I'm gonna play around with some peripherals. I want to do some more hardware stuff because this is basically creating a server, right? I didn't even install my desk camera because there's nothing to see. So next time we'll do some more hardware again. Take care, everybody. See you soon. Bye.